Welcome back to CloudOps Lab. This is episode 5 of the DevOps Foundation series. So far, we have built the foundation. We explained CI/CD, we built a GitHub Actions workflow, we Dockerized an application, then we looked at how a container can be deployed to AWS. Now we are ready for Kubernetes. Kubernetes can look intimidating at first because it has many objects, many commands, and a lot of new vocabulary. But for beginners, the core idea is simple. Kubernetes is a platform for running containers and keeping them in the state you asked for. You describe the desired state. Kubernetes works to make the actual state match it. For example, you can say, run 3 copies of this container image, expose them on this port, and restart them if they fail. Kubernetes then schedules the containers, watches their health, and replaces them when needed. The smallest running unit in Kubernetes is called a pod. A pod usually runs one main application container. It can also include helper containers, but beginners can think of a pod as the wrapper around your app container. Pods are temporary. They can be created, destroyed, moved, and replaced. That is why you usually do not manage pods directly for real applications. Instead, you use a deployment. A deployment says which container image to run, how many replicas you want, and how updates should happen. If you ask for 3 replicas, Kubernetes tries to keep 3 healthy pods running. If one pod crashes, Kubernetes creates a replacement. If you release a new image version, the deployment can roll out the new version gradually. This is the first key mental model. A deployment manages pods for you. The next object is a service. Pods can change names and IP addresses. A service gives them a stable network address inside the cluster. Instead of sending traffic to one specific pod, traffic goes to the service, and the service routes it to healthy, matching pods. This is the second key mental model. A service gives stable access to changing pods. Now let us talk about labels and selectors. Kubernetes connects objects using labels. A pod might have a label like app equals web. A service uses a selector to say, send traffic to pods with app equals web. This is powerful because Kubernetes is not hard-coded to one machine or one pod name. It groups resources by labels. The third key mental model is that labels connect the system. Now imagine you want the application reachable from outside the cluster. There are a few ways to do that, depending on the environment. You might use a service of type load balancer. In cloud environments, that can create an external load balancer. You might also use an ingress, which routes HTTP traffic based on host names and paths. For beginners, remember this. Deployment runs the app, service gives it stable access, and ingress or load balancer exposes it externally. Now, let's discuss configuration. You do not want to rebuild a Docker image every time a setting changes. Kubernetes provides config maps for non-secret configuration and secrets for sensitive values. A config map might store a feature flag or an API-based URL. A secret might store a password, token, or connection string. Even when using Kubernetes secrets, you still need good security practices. Do not commit secret values into Git. Now, let us connect Kubernetes to CI/CD.
Your pipeline still starts the same way. It tests the code, it builds a Docker image, it tags the image, it pushes the image to a registry. Then, instead of manually logging in and changing things, the pipeline updates the Kubernetes deployment to use the new image tag. Kubernetes performs the rollout. If the new pods become healthy, the rollout continues. If they fail, the rollout can stop or be rolled back depending on your setup. This is why health checks are so important. In Kubernetes, health checks are usually called probes. A readiness probe tells Kubernetes when a pod is ready to receive traffic. A liveness probe tells Kubernetes when a pod should be restarted. Without probes, Kubernetes may send traffic too early or fail to restart broken applications. Now let us review a beginner Kubernetes deployment checklist. Create a Docker image for the app, push the image to a registry, create a deployment YAML file, set the image name and tag, set the number of replicas, add resource requests and limits, add readiness and liveness probes, create a service for stable internal access, expose the app with ingress or a load balancer if needed, keep configuration in config maps, keep sensitive values out of Git and use secrets or an external secret manager. Deploy from the CI/CD pipeline, not from a laptop. Watch the rollout status. Check logs and metrics after release. If you understand this checklist, Kubernetes becomes much less mysterious. You do not need to know every object on day one. Start with deployment, pod, service, config map, secret, ingress, and probes. That vocabulary is enough to understand many real-world Kubernetes deployments. The full DevOps Foundations flow now looks like this. Git stores the code. GitHub Actions checks the code. Docker packages the app. A registry stores the image. AWS or Kubernetes runs the image. Monitoring tells you whether the release is healthy. That is the foundation. If you want a Kubernetes starter YAML checklist, subscribe to CloudOps Lab and comment Kubernetes. In the next series, we can go deeper into real hands-on projects, including pipeline templates, Docker files, AWS deployments, and Kubernetes manifests. DevOps is a system. Once you understand how the pieces connect, every tool becomes easier to learn.